Okay, let us begin for today for our workshop for today. Couple things I'll make note of before we even begin. I posted, and I'm just going to repost this again, just in case it needs to be. Here is a link to the GitHub account that we'll be using for today. Everything in there should be can be used to create everything that we'll be talking about today specifically. So you should be able to see all the files needed for it within Jupyter, and also the files needed to create the graph network, and also shape files and all this stuff to get to create maps and the networks themselves. Also, if you go to that link, you'll see another link that'll go to the presentation itself. For today, what we'll be doing specifically is looking at creating a network graph and also a map as well. It's one of the things I was able to learn from yesterday's conversation with the group here at the live presentation was trying to limit some of the specific conversation to just kind of most of the coding involved, and just kind of making sure people sort of understand what the thought process and actually making the visualization. So there might be a couple small changes. If you happen to look at the code earlier today, I made some small changes in GitHub. And so for the most part, a lot of it's the same, but for some of this, it's small changes here and there, but I'll talk about that as we move forward. I'm going to share my screen here. A couple things to make note of. Like I said, first thing, sort of the expectation is that you are able to install the Anaconda program. Anaconda is sort of it's a way for us to kind of put some code together and run it within the browser itself. If you happen to not been at the first workshop, one of the issues we can run into in a lot of this is the fact that if we were trying to develop some of these D3 visualizations, because it's a JavaScript library, and this is something that has to run within HTML itself, it's something where we'd have to set up an actual web server, kind of set up configurations for that. Jupyter kind of lets us sort of negate a lot of that stuff. And so whenever you open up Jupyter, you're going to see a couple tabs. If you downloaded one of the newer ones, you'll see something called Jupyter Lab. That's actually something that's been relatively new in terms of some of the new progressions and some of this, and might be something we'll use for future workshops. But for the most part, we're going to be using the Jupyter Notebook itself. So you're going to click on that and launch this directly from there. If you go to the GitHub account, the way to actually download this and get this sort of working for you is to actually go to under Dudas PM, and it'll say Data Workshops. You're going to see a couple listed there, one for the last one for this one, Workshop 2. All you need to do is actually click on Clone or Download, and you can download it as zip. Once you actually open up Anaconda, if you don't know exactly where to put that particular folder, you can actually go into Projects, and then whenever you add a new project, so yesterday I added one called Test, it'll tell you the home directory. So for me, it's C users PMD19, and then I have a folder I specifically created called Anaconda Projects, and then anything that I need to put in there, I'll put in there for the actual presentation. So for that, I would specifically go and say, clone and download the zip. It'll download for me, and then I would just take that, unzip it, and drop it into that Anaconda folder that I just mentioned. Let's throw it into, and stop the copy error, so replace. There. And so for us, it's going to be, you're going to see a new folder called Data Workshop-Master, and you're going to see Workshop 1 and Workshop 2. One thing I'll make note, just in case you're just joining the conversation, everyone is muted, at least from what I see here. So if you have questions, please use the chat, and I'll keep an eye on that throughout the conversation. Even if you just kind of like raise your hand or something like that, I can sort of unmute people to make sure we get all questions answered. But we're going to be going through and using Workshop 2 specifically for today. So if you go, once you load up Jupyter, it'll open up in a new tab. And if I go to the home directory, like I said, I have a folder that I specifically created called Anaconda Projects. And you're going to go into there and find Data Workshop-Master, and everything is going to be inside here for you to utilize for today. The first thing we are going to be talking about is creating the network graph itself. And let me actually get to my slides real quick, just to kind of keep on target. Actually, I should do a quick little introduction sort of myself. I ran these, this is the second sort of workshop that I've put together. I also like to say special thanks to the Institute for CyberSciences. They sponsored a lot of these. They sponsored these workshops for me, and teaching and learning and technology has helped as well, specifically finding a location here on campus for the live events. But I specialize in data visualization, social media, and data analytics, and I support here at the Huck Institute for Life Sciences, the Institute for Cyberscience at Everly College of Science as well. And for, like I've mentioned before, these workshops sort of incorporate sort of the art, the data, the coding, and the UI, UX, which is user interface, user design. So I've already kind of talked about sort of the startup screen, environment variable, environment in terms of, one of the things we're going to be doing today is also, we'll probably be skipping this step specifically. This is specifically with Python, but I'll come back to that in 1 second. So for us, we're going to be in the network folder. Originally, yesterday, when I went through these, I actually had a script here. And this first cell here, and to actually go and run some of this information, you're going to actually see that it's going to have different cells. So this first one here that's highlighted green is one cell. One of the things you're going to see is the fact that you can go cell and then run cell. And if you would happen to run this first cell, it's not going to work out specifically because of the fact that I was actually going to showcase how to install a couple libraries. This is a Python script right here, and what this is actually creating is a random graph. Just to kind of talk through some of these things, one of the things you need to install is something called NetworkX. It's a library that's open source and lets us create these random graphs. But for today, I actually went through and created a random one, or actually downloaded a pretty popular one for network graphs, and I'll be using that specifically as a way to sort of showcase how to create the visualizations themselves. So this first part here we won't be actually utilizing too much today, but I kind of want to stick to something that's a little bit more known, if you will. And this is actually a data set tailored to Les Miserables, and looking at characters and their occurrence within the story structure. So you'll kind of see, the main characters sort of highlighted, but you see sort of the back and forth between these characters. And this is actually kind of one of the default data sets that a lot of people utilize for network graphs. So I decided to use that again. A couple things to note. It's kind of a lot of information here, but for the most part, the things that I'll kind of highlight is the fact that you have two sections. I'll kind of break those out for a second. That is nodes and links. If you're the basic 1-2 in terms of network graphs is very kind of crude drawing in terms of what I'm showcasing here, but a lot of times when you think about networks, specifically something like a social network or a conversation network or email network of some sort, you have individuals, and at some point these people might sort of converse with one another. So we're assuming Sally talks to Matt, Sally talks to Bob, and Bob talks to Dave. And how we're going to represent that today is we're going to be representing them specifically using something called nodes, or another term that people use is vertex, and links. Links or edges are basically. And so we have 4 nodes for our 4 individuals, and then links connecting those two individuals as well. In this case up here, I have a directed graph, so that basically means Sally is talking directly to Matt. But for our case today, we're just going to assume that they're sort of equal in terms of their undirected, if you will. And so we have nodes and links sort of set up for that specifically. Another thing that we kind of see within this data set is something called clusters or groups. And all this basically means if you would look at this network sort of as a whole, a lot of people generally converse or talk to one another. So in this case, if you would have a network like this, you'd have basically, because these people are talking sort of a lot with each other and they're separate from sort of the rest of the graph, they should more than likely be sort of created into a group, a community, a cluster, clique, or like I said, there's different terminologies for this. Today, I'll just be referring to them as a group. In the original code, in my little script up here, basically, I also included a community, basically algorithm. Again, I'm not going to go into too much detail because it's a little bit outside the scope of what we're trying to accomplish today. But for the most part, it's basically, it'll sort of do this automatically for you, if you will. And this is just, again, sort of partitioning the network. So it says, well, these people are highly coupled or highly communicating with each other. They're probably put in a group. versus ones that are just sort of separate from that particular sort of a group and sort of conversation, if you will. So for our nodes, we're going to have names, so the individuals within, again, the story structure, and then group is already sort of calculated for us. And so each of these nodes basically has those two types of information. Our links are going to have basically 3 types of information. That's a source, a target, and a value. Value is technically not needed. Value in this case is basically sort of how often those people sort of converge, or sort of talk with one another, if you will. And so that's sort of like meta information. The most important 2 things is basically the source and the target. The source basically saying, indicating 1, meaning our node. So if you kind of go through here, we have node 0, node 1. So this would be Napoleon, and target would be 0. And so for this, basically, you kind of work through this. And so this is your way of connecting the dots, if you will, literally and sort of figuratively as well. So where we're actually going to start is on this script part here. And what you're going to see is if you would run this and you go to cell, type 1 cells, nothing's really going to happen at this point. And to be quite honest with you, this subsection here, kind of redundant. I do this specifically just to showcase how you can add additional little pieces of meta information or other types of information that you might be interested in adding as well. This is basically going to be the structure for the rest of the visualization part of it. One question I got from last time as well is basically within D3, is there ways to actually import files? And there's actually a couple different ways of doing this. The file format that you're seeing here is something called JSON. And so what we can actually use in D3 is basically a JSON reader. JSON basically is sort of a way of formatting data so you can sort of remove some of the redundancy that can kind of occur with like something like a CSV or comma separated values, or TSV, the tab separated values. And so what this will do is it'll produce 2 different things for us. It'll create the data set, so graph, and 2 parts, nodes and links. And those are basically subsections. So for there, we're just running through each of these. So that's what that for each basically means. It's for each of those nodes. We're going to create, again, this is very much redundant, and I sort of acknowledge that. But again, this is sort of just making sure we connect, have all our information up front. So first thing is basically you're going to have the graphs for each. We're going to create a new array. So sort of the same thing. And then for source and target, same idea. We're just going to make a reference to the nodes up here, and to sort of just make those connections for D3. And if you want to, you can actually change this back to the graph.json. It should work as well. And for the most part, if you kind of follow this script where you have naming structure, maybe you have a group, you don't necessarily need this, but you have a group, and then sort of source and target. For the most part, you can just sort of use this script over and over again. So for us, this is actually where we start getting to the visualization part of it. And if I run this, you're going to see sort of at the bottom here, our network structure. So this is actually the Les Miserables data set being visualized. And as you can see, if I rerun this, it'll sort of, based on the data that it currently has, it'll sort of restructure this information for us. So for the most part, this is going to be the same thing throughout, and there's going to be small changes throughout as well. But for the most part, I kind of want to spend a few moments just kind of making sure that we sort of see what's going on specifically with this. I also added a couple of places in terms of, I'm going to spend a few moments here just because this is sort of the main script. And there's going to be some parts of this that I'm going to just sort of assume that I'm not going to go into a lot of detail with, just because a lot of it's sort of handled in the background. I'll have links, as you can kind of see throughout, that kind of gives you, if you want to change this variable, what can you change it with, and things of that nature. The first thing you'll notice is that we have these percent JavaScript. All that does is say to Jupyter is what's going on here is JavaScript. And we just have to declare that once. The second 2 parts here are, again, sort of specifically for Jupyter. We're adding an element called a div. A div is basically, it's basically in HTML, a divider. It's basically a placeholder for us. And as you can see here, we have a div ID equals graph1. And all that means is basically that we're going to add an element, which happens to be right here. Ignore the graph for the moment. and it's going to be our placeholder, and it's going to have an ID called graph1. And this is, and we can put some style information in terms of sort of the width and the height, and the margin 0 auto basically means we're going to center that specific div. So all that is basically sort of a placeholder for us. And this is something you probably copy and paste in any type of project. The next is a required statement. All this does is basically go out, find this D3 library. So this is something that's online, and lets us sort of use this as a JavaScript library. And one thing I'll note is D3 is an open source library. So basically you can utilize it for projects, for profit, things of that nature, commercial, academic research as well. It's basically open in that regard, as long as you cite them. It's under, I believe, the MIT license agreement. So you just basically specify that. That'll give you sort of a pathway to say that anytime you reference D3, which you kind of see here, we're referring to that specific library. So one of the things I also have here is the original example. So if you're interested, you can actually go check out this link. This is where the original project was done. There's a number of different ones. Mike Bostock is basically the creator of D3. He used to work for the New York Times, did a lot of those New York Times visualizations that you might have seen in the past. But he was the creator of D3 and ProtoViz, which was one of the original versions of D3. But for the most part, he has a number of different examples that you can kind of go through and try out and play with. Some for curved edges, fisheye distortion. Won't go into a lot of these for today, but sort of a great resource to utilize if you're interested in looking at different projects. So for us, the first thing we did, like I said, we create that div, we give it an ID. The second part here is the select statement. These select statements basically say, on this web page, I want you to find me the div, and this hashtag or pound sign, depending on how you want to call it at this point in time, basically says to the browser, ID equals. So this sort of reads out div with an ID equal to graph1, and that's what we've created up to this point. All this line does is basically it says, I want you to go select that div, and anything that's inside of it, I want you to remove it. And the reason I have that is the fact that if we didn't have this statement, and I can actually show that now, if I remove this and I'd run this again, we would actually start getting a little bit of redundancy. I don't know if it's actually show all of it, but yeah, we would actually, it's towards the bottom of the screen, unfortunately, but it's basically, it's going to create some redundancy on our graph. And if our graph would sort of overlap with one another, you'd actually see this. So I won't go into too much detail. Basically, this just keeps clearing that div for us each time. The main things is basically some of the key characteristics or some of the variables are like width and height. We set that ourselves. You can change those as you see fit. The first thing is actually we're going to be creating sort of a structure in terms of an SVG. D3 uses something called scalable vector graphics. SVG sort of, I'll be sort of referencing that from here on out. And so the nice thing about the SVG is the fact that it's a situation where it uses an XY coordinate plot, and no matter how far we sort of zoom into this, so if I go back to my example here, D3, and I start zooming in, you can kind of see that the actual graph itself doesn't deteriorate at all, because what it's actually doing is just recreating the XY coordinate plot. It knows that these circles are supposed to be at a specific location, and those links are supposed to be at a specific location, so they just kind of redraw that specific space, which is really nice, especially if you want to use things like this for publications or posters. Basically, they're kind of almost like infinite size, is basically to whatever specific specifications you need for that particular, again, document or that particular poster. And so what the first thing we do is basically we need to have, so we have our div to place our graphic in. We need to actually have the SVG sort of specified, so we know that we need to put the SVG object somewhere. So one of the things I also added to the documentation here is, as you can kind of see, is a link to something called W3 Schools. W3 Schools is actually sort of a resource I'll use a lot of times just to kind of get some basic ideas of how to create or develop code for things like SVG or HTML or CSS, but basically it sort of has a wide library for you to try out and sort of play with in terms of some of the basic code, if you will. And I have a couple of specific links for the circle and the line objects, and considering that's what we're using today to create the nodes and links on these given graphs. So if we go into the circle, what like I mentioned before, it sort of gives you sort of a template of what you need to create this particular object. So again, you sort of see the SVG sort of case or outline. So you have to have sort of that first object, and then inside there you have to put whatever sort of it's called a viewpoint, but basically it's sort of a canvas or a way for you, first to sort of to say that there's going to be an SVG object here, and how they sort of the basics in terms of the height and weight, width specifically. The other thing that mentions is sort of like the circle we'll be creating. We're not going to worry too much about the fact that we need something, the CX and CY, which is basically the location. Because we're using the force-directed algorithm, this will sort of be calculated and set for us pretty much automatically. But the other thing we're going to need is the R, which is the radius as well. And we can hard code that, or we can sort of have it based on number of connections or things of that nature. This rest is basically just sort of lets you sort of stylize. So the stroke being the outside boundary, so that'd be a black color, and then fill would be red, obviously, and then sort of stroke width is basically how pronounced is that stroke specifically. The other piece of information we're going to need is the line. So again, sort of shows you just the basic example. In this case, for a line, we're going to need 4 pieces of specific information. That is the starting X and Y positions and the ending X and Y positions, and that's designated as X1, Y1, X2, Y2. And again, some styling as well, but for the most part, this is what we're going to need. And again, the force-directed graph algorithm is actually going to take care of this for us, so we don't have to worry too much about that. And then going back in, that'll kind of give you an idea of what key characteristics we're going to need. And so we have here circle, radius 5, and then line, just some basic information. But at the bottom is where it's actually going to be specific to where the locations are going to be for that. For us, that's going to sort of help us represent, again, sort of those nodes and those links. We're actually going to start here in terms of some of these characteristics, and then we'll come back to this part that says simulation. That's going to do the simulations for the force-directed graph itself. But for now, we're just going to start here for links. And what we're doing is, once we create that SVG object, so that outside container, we're going to append, in this case, we're going to append a new group of points or objects. And specifically, we're going to be adding lines. And then this point is actually where we're going to start feeding in the data. So again, this links is referring back to links here. Again, we did this a little bit redundant, but for the most part, we're using those links to sort of highlight, for the most part, it basically is an array of information. So links, the source, the target, and the value. And so we're just feeding that into D3 to say, we're going to need you to make as many links as we have in our data set. So if we go in here, we have, I'm not going to count all these, but for the most part, say 200, 300 links. We don't want to manually sort of encode all this. So we're just letting it sort of say, for each of these values in our array, I'm kind of highlighting them one at a time, we need to create a new line, if you will. And the same idea for nodes as well. For each of these, we're going to create a new circle or node in this case. And so you do this for links, and we do this for the nodes themselves. So we have circles for our nodes, links, lines for our links. And the one thing you might notice at this point is the fact that I don't actually declare their location. All I'm just saying at this point is we're going to have 200 links, 100 nodes. Let's just put it that way. And one other thing you might notice as well is this coloring as well, and I'll come back to that in 1 second as well. So for this, if we would just run this at this point, then I can actually just show you what happened. Nothing would actually show on the screen at this point because I've not given them a location to put the nodes and actually lines themselves. That's where actually this simulation part comes into play. And this is one that's built in natively into D3. The force-directed graph, using specifically the force many-body sort of approach to this. Think about it in terms of for each of our nodes and our graph, they're going to maybe have like sort of a pulse rate or charge between them, so they're going to push each other apart. Links are going to be basically sort of set in terms of we want them to be sort of this long, 10 pixels long each time. And we can set and change those, and I'll show you how to do that moving forward. But for the most part, we just sort of need to declare, that we're using this simulation and sort of just some basic information at this point. one of the things you might see is the center part. All that does is say, well, we're going to have, on the screen here, where do you want to actually put a force-directed graph? And so we set the center to width half, height half, basically the center of that div or that object. That's just basically sort of works in that regards. From there, the simulation, we just have to tell them where are the nodes. And again, this nodes here refers to our array up here, so this array. And we tell them where all the links are. Again, we're going to say the links from the array as well. So it basically knows that it needs to work with these nodes. They're going to be on the screen, so about roughly 100. And we know that these certain links are sort of connecting all these nodes as well. So for us, it just sort of, the simulation takes care of a lot of the thinking about sort of where to place these actual objects. So for the most part, we've kind of covered most of what's going on. We sort of just have to touch on the fact that we need to know where the placement is. That's where this ticked function comes into play. You can see here on tick, we want you to do something. And basically, when you're running a simulation, it's going to sort of try to get to sort of a final position, and it's sort of going to try to get you sort of an optimal position for this network graph. Again, I'm not going to go into too much detail in terms of the algorithm that's sort of running in the background, but for the most part, we're just using this to say, for each of these ticks, and these ticks happen very rapidly, so we're going to run through about 200 and 260 of them within a second or so. And for each of these ticks, and as it gets closer to a final sort of simulation, final sort of layout, if you will, we want you to move our link, move our nodes to their actual sort of locations. And so this is actually taking care of this for us. So for each of our nodes, it's setting that the X value and the Y values to wherever this sort of simulation needs to put it. And again, the attributes for X1 and Y1, so our starting XY position and our final XY position is going to be handled by where the source and the target sort of should lie, basically. And again, this is something that you just kind of copy and paste through a lot of these projects, because this is very standard for a lot of these projects. So for the most part, you're going to kind of utilize this as a good starting position. And if we run this, like I said, you're going to get sort of this output moving forward. And if you want to, you can change some values just to kind of see what it looks like. So if I really wanted to go with the stroke width, that's basically how thick the lines are between each of the links. I can rerun this, and now they're really, really thick because I changed them from 2 pixels up to 10 pixels. And if I wanted to come back here, go to 1 pixel, rerun this again, and now they're obviously a lot thinner at this point. You can tie that the width to sort of values, and I'll show that in a couple seconds here. You can change a lot of things based on the data itself. D3, specifically, D3 stands for data-driven documents. It's going to help you a lot of times with making sure that you're taking just data or information and repurposing it for the visualization that you're trying to put together, basically. It's going to take care of a lot of the things and let you use the data to sort of create the graph. So it's less manual processing that's actually going on, less skew and error. You're representing the data as actually very accurately in that regard. So it's basically sort of taking a lot of that nuance and actually sort of helping you through that process. And again, you can sort of control a lot of these variables, a lot of these changes. One thing you might have noticed is, like I mentioned before, is coloring. Basically, D3 has a standard way of doing this. These are sort of the default values. I just need to include this line here, and what it'll do is actually sort of create an ordinal scale. Basically, it'll let me sort of say for each data point within from 1 to 20. So this is category 20. So there's 20 colors that I can sort of utilize. It's going to automatically sort of take care of a lot of that issues for me. So it's not, I don't have to specifically say for group 0, I want you to be this color. For group 1, I want you to be this color, and so on and so forth. It's basically going to use this color spectrum, and for each new sort of data point, if you will, it's going to color them appropriately within 20 colors because I'm using that specific one. If you're interested, you can go check out the website. There's a number of different color schemas that you can sort of utilize. If I want to, I can set this to 10. We run this again, and for the most part, you're going to see that we're going to have a little bit redundant at this point. So we have a group here that's blue, and it's blue over here. Basically, all that means is in our data set here, more than likely we have groups that go past 10 at this point, so maybe up to 11 or 12. So basically, that's why it kind of goes over that threshold. So I'll set that back to 20. Okay, so back to 20, and you run it, and for the most part, it should reproduce back to sort of having that scale again. So that's how you sort of start off with creating the network graphs. From here, basically, we can make some small changes here and there to highlight certain things, to change different variations, to change up styling, to sort of help sort of increase some of that knowledge if you're, or sort of that highlight certain things and style certain things as well. So at this point, basically, if we run the next cell, it should sort of, you should see something that sort of looks similar to this. It's going to be slightly off, maybe a little here and there for the most part, but for the most part, you should see a network that sort of looks like this. Again, this is using that same data set. Some of the other things we can add to this is within our simulation is the fact that we can add, again, we've talked about this, I mentioned this before, but we can add distances between each of these links. So it knows how far to push each of these links, and excuse me, all these nodes apart. And we can actually be a little bit clever in this regards. So in this case, all I'm saying in this function here is that if the group, the source node or the source circle is in the same group as the target one, so in this case, if we go down here, so these orange ones, there's a link between these two oranges. And for the most part, we want to say that if that's true, we want to bring them really close together. So I'm going to change this number to 5. And this is a sort of true-false statement. So if this is false, this number here will apply. And I'm going to make this 100. And so if I rerun this, we should see that basically all the ones in the same group sort of pull themselves closer together, and all the ones that are sort of outside of the group, so basically everybody's kind of really close together, and then links that are outside of, so if there's a light blue here to a peach color here, basically that's going to be 100 pixel apart. They're going to push each other apart as much as they can. And you can sort of, if you can imagine sort of playing around with this to sort of, again, sort of highlight groupings, or if you wanted to do it the opposite way, so if I change this and say 100 this way, and say 10 this way, you're going to sort of see it's kind of all kind of meld together, if you will, because of the fact that, again, we're biasing towards pushing group nodes away from each other, and then pulling nodes that are outside of group sort of membership closer together. Going through that, and there's a couple other sort of functions we can do as well. For the most part, we can bias where the X position and the Y positions are. At this point in time, so if I wanted to, one other thing I mentioned as well, you can actually not only just set a distance between each of these nodes, and you can actually set a strength as well. So let's assume that we wanted to set the strength for all these links to 0. If we run this again, you're going to find that you're going to have a very sort of relaxed network, if you will, because there's no sort of force pulling each of these nodes together, because it's sort of ignoring all these links on the screen. And you can sort of set that between 0 and 1. So I'm going to set it to 0.5. And for the most part, it should look like, set this back to 20 and 50. For that. Okay. We can sort of set it to that. A couple other things you can also see as well. You can sort of set an X value and a Y value, so you can have it specifically try to be at a specific location. And also things like charge. So charge is basically how much the actual force directed graph sort of pushes nodes away from each other. And I have a note here that basically says if it's a positive value, so the strength at this point is negative, it's actually sort of using a charge that's trying to push all the nodes away from each other. If we set that to a positive, it's basically, let's do that now. I'll show you what happens. It's basically all the nodes are trying to pull each other closer together towards the center position. It's not very informative, obviously. But if we want to, we can go on and say, let's set this to 300, and it's really going to start pushing all the nodes sort of away from each other. Again, sort of that's sort of the charge factor. The collide factor basically is the actual node repulsion itself. So if I set this to, let's say 10, again, it's going to do just specifically with the nodes themselves, sort of push all the nodes sort of away from each other. And so if I set this, and again, you can sort of play around with this if you want, just to see how these different values change what's going on. So I can go and set this to 100. They're really trying to push each other apart at this point. And again, sort of change things as you see fit. Something kind of cool, fun to play with, if you will. Moving on to the next cell. The only thing that's going on that's a little bit different here is that I changed up the stroke width here to be sort of utilizing that value that we talked about before. So all this is basically saying, for the stroke width, I want you to actually use the data to sort of showcase how thick the lines are. So if we run this, we're going to see that we have a lot of dark lines between some of these individuals. And for the most part, all this is telling us is the fact that these individuals are really sort of interacting with each other within this Les-Miserables data set, if you will. Whereas these thinner lines are sort of saying that maybe the only co-occurrence happens only once throughout the story. One last thing I'll mention is you can actually do something called dragging. And this dragging specifically allows you to click on a node. So I'll do that here. And sort of drag it around, so you can kind of make it sort of a movable object. And all you need to do is actually add a couple of different sort of set criteria in terms of a drag started, drag while you're dragging, and then drag ended as well. And this is something that a lot of times, you're going to sort of have that by default. If you go back to this force-directed graph here, these are basically just sort of default values. It's not something I put together. It's basically their calculations and things of that nature. So a lot of times I'll just copy and paste this. But for the most part, all it does is allow you to sort of add a little bit of functionality to it in terms of now we can sort of set our graph. So we create our graph, and now somebody can go and click on it, drag it off this position here, move it around, see what happens as you move it around. And if I change, let's say, the collide, so everybody's really trying to push each other away, go back down here, and click on this node, and as I move it around, you see basically all the other nodes are kind of trying to get away from it, if you will. Think about this in terms of like two magnets with the same sort of positive charge of one another. They're trying to repulse each other at that point. So that's kind of heading into this first sort of point in terms of this is how you create that network graph. And for the most part, again, try to go through and just maybe change for the values, see what's going on. Maybe put together your own data set to see what would happen with some of the, how this should look in this regard, and then just play around with some of these changing these values as you move forward. So that's the network graph sort of portion of the conversation. What I would like to do now is actually head over to sort of the map structure at this point. So network graphs basically sort of are handled in this data set. And if you go into our data set here in terms of the workshop 2, you're going to see basically that we have another file called map, and I'll open that up here. And from here, basically, there is some code that's going on, and I'll walk through this as we kind of need to. The first thing I'll make note of before I move on to that part is, go back to my presentation here. I skipped over a little bit of this information, a couple of sort of topics in terms of network graph theory, some of the ways you can add sort of information to this stuff. What I recommend is basically kind of walk through this and take a look at it at some point. For the most part, it's just basically some trolley measures, so you can add that information into the network graph to then make it more interesting visually. There's some social science topics as well that you can kind of look into. And again, I'll kind of let that go just for the conversation for today. On our map, we're going to actually go through and talk about, and I'm going to kind of skip a couple slides for a moment here, to sort of outline today's project, if you will. Our project is basically going to be, I want to create a map of the U.S., including Alaska, Hawaii, Puerto Rico, basically anything that's sort of under the U.S. umbrella, if you will. And for the most part, we're going to then limit this map to Pennsylvania, and this is going to be by county. I'm going to go out and find data for each of these counties, and then basically color code our counties by population. So this is sort of outlining what we're going to be doing today. A couple things I'll make note of is the fact that one of the main topics we'll be talking about is something called a projection. one thing you have to consider for when you're creating maps is the fact that you're trying to recreate obviously a three-dimensional object, which is obviously the Earth, and you're trying to project it onto a two-dimensional plot, which is your screen. So you have to think about how do we project that onto that screen. And I kind of like this diagram in terms of if you would put a light bulb inside the Earth and sort of how this would actually project out and how people typically will see a normal map and how it can sort of lead to some incorrect sort of proportions a lot of times, especially over the northern and southern parts of the hemispheres. So there's actually an interesting project I recommend going and trying out. It's called the True Size. It's kind of a cool little thing. Basically, you can sort of type in a country or a continent, and it'll give you the size. And again, this is sort of a default map that we typically would see in like Google Maps or anything like that. The one I chose in here is basically I have the United States, and then I also have Greenland. So this actual small little blue object here is Greenland. A lot of times people sort of assume that Greenland is sort of this massive area, which it is, but not this size. Basically, the issue is that you're projecting the top part of that sphere onto that two-dimensional map, if you will, and its actual size is smaller than the United States, about a quarter the size, if you will, the continental United States. So check it out. It's kind of a neat little way to sort of showcase sort of different proportions that are actually true in terms of the actual sizes of these continents or countries. For us, the first thing you're going to do is you're going to go out and try to find something called a shapefile. Now, one thing I'd like to note is the fact that when we're talking about creating a map, one of the questions I got yesterday was the fact that can't I use just something like an ArcGIS or QGIS to sort of create a static map? And that's very true. What we're going to see today is not going to be sort of groundbreaking in terms of things you might be able to do in software packages like ArcGIS. For the most part, you're going to have, this is just sort of starting in terms of just trying to meld two pieces of information together, that being the shapefile of the United States, and then adding some additional information like the county population information. And you can sort of build out from there. But for the most part, if you're just looking to create a static image, ArcGIS is going to be sort of one of your best places to go to start and put this together, or QGIS is another resource as well. But I'm still going to walk through just because, again, you can sort of build out more dynamic maps, some interesting things that you can kind of put together. But the first thing that we need to do is actually find something called a shapefile. A shapefile is basically it's how these maps are being created, and basically it's sort of an agreed upon standard in terms of a lot of mapping structures. So if I use a shapefile sort of from this location, specifically I'm using from the Census Bureau, basically the map of the U.S., we can sort of have an agreed upon sort of way that the United States is going to be formatted and how it's going to look and its dimensions, and it's going to use something called like their latitude and longitude to actually etch out all the states. Again, sort of using Alaska and Hawaii as well. But it's sort of an agreed upon sort of standard, if you will. If you go to this website, and again, I'll make a note of the fact that if you go into our folder that you downloaded, you should have all the information, so we don't have to sit here and sort of wait for all these things to download. If you go to that website, you can kind of see that you can download different things in terms of the congressional districts, zip code sort of maps, which is a very large file because it's actually a lot of detail that people don't really know, sort of, I've created zip maps before. But for the most part, county is sort of enough little small details for us to kind of play around with. And you can download these and sort of try these all out. But for the most part, I'm going to talk about the county one. And that's what this file called CV 2016 US Counties zip folder is. Again, if you were using something like an ArcGIS, you would just open this up and maybe sort of, add the additional, information like another, outside folder, like a raster folder or file of some sort. But for us, we're going to kind of walk through all these sort of ways to actually create the map using D3. There's a couple resources that you can actually use through ArcGIS to do to create sort of what data structure we need to use. But I actually have a couple links in my presentation, a couple of ways to actually convert this so we can handle this on, basically, these are open source projects that allow us to do it pretty straightforward. This first one, so that's right now. You would just take that, I'll show you what I mean. You would just take that zip folder of the shapefile, drop it right here, and click Convert to JSON, GeoJSON. And for the most part, all you need to do is sort of copy and paste this screen. For the most part, that's going to be enough to kind of get us started in terms of this is the structure of the data. Again, sort of taking care of sort of just placing out the actual states and also providing us that sort of guidance in that regard. So we don't have to actually sort of start from scratch, if you will. So all I did was drop that shapefile in, and it exports this out for me automatically. A nice little resource, again, free sort of resource online for us to utilize. The other one I have listed here as well is something called MapShaper. And MapShaper is really nice to help us, especially with very high detail maps, if you will. And so if I want to, I can go back in here. So this output is the one that's called US JSON. I can just drop it into here, and it'll actually show just basically give you an outline of what you would actually see in the shapefile itself. Again, you're going to see Alaska, Hawaii, and so on and so forth, in the continental United States as well. And you're going to notice something as well, if I move this over. Alaska, because it sort of wraps around the world, it actually has parts of it sort of sticking out on the other side here. What this can let you do is sort of simplify these maps if you would like to. So if you go into, there's a button here called Simplify, and I'll just kind of show you what happens if you simplify them. So I'll zoom in, and as I simplify it more and more and more, you're seeing a lot of those lines become straight lines. So basically, it loses a lot of its details, if you will. But this is just nice, again, sort of if you were looking at a larger zip map, if you will, with a lot of different lines and things of that nature, you're gonna need to sort of simplify these maps a little bit. And again, it's just a free resource to utilize if you ever need to, and then we can just export that as need be. So at this point we have, and what you have here is basically, we're gonna be using this us.all.json file, and that's gonna be basically this map here. And that's gonna be sort of our starting point for creating these maps. The first thing I'll make note of is the fact that this first cell, now that we're back in Jupyter and they're under that maps folder file, the first thing you're going to notice is a script here. I call this the map scaling magic. This is something, a function that I've put together through my time working with maps. I don't want to go into a lot of detail with it. It basically creates a function called create scope. We're just going to use that throughout here. And what this allows us to do is basically, we can say, based on the width and height of the window we're creating our map in, so whatever this width is, so let's say 8 by 100 by 1000, or 800 by 800, or whatever this sort of screen size is, we want to create the map so it sort of it maximizes that space. If you don't have this, you're going to have to sort of play around with the scaling back and forth. Again, something I'm not going to go into too much detail, but sort of something I utilize for a lot of times, because if I have a map that's taking up, again, sort of an 800 by 800 space, I don't want to have to think about sort of how do I scale that to that particular screen. Or if I'm using the entire screen, again, I don't want to have to think about that in terms of handling that. So this sort of is just sort of a magic function that I've used before. And again, I'll leave it here just so you can utilize it, but I'm not going to go into too much detail in its regards. But it's going to be used throughout the rest of these conversations, these cells, if you will. So what we have next is basically the actual sort of outline of for creating the actual map itself. One thing I'll make a note of is the fact that I've also included a link to where I kind of got the original inspiration for this project from, linked up here. As you can kind of see here, kind of gives you an idea, obviously the United States here with Alaska and Hawaii at the bottom left-hand corner. And sort of kind of go through just sort of, again, we're not going to follow this word for word here, but for the most part, this is sort of the inspiration for the actual graph that I'll be talking about here in a moment. So the first thing I'll make note of, or as I kind of mentioned before, is that create scope. And again, this is sort of adhering to whatever sort of width and height. So in this case, we have an 800 by 1000 window that we're going to be creating this in. So basically, it'll sort of automatically tailor the shapefile to maximize that space for us. And so I call it just a variable scale. So going through this, as mentioned before, we're going to be referencing us.all.json. This will be a JSON file that will allow us to create the entire United States, including Alaska, and its sort of correct positioning, if you will, on Hawaii as well. So when you bring in the data sets, we first have to declare a specific type of projection for this. And there's a number of that are actually available for us to sort of choose from. And I'll just open this up real quick here and sort of let you go through and sort of see some of the available ones that we can sort of change to. And I'm going to kind of skip to the bottom here. There you go. These are actually the projections themselves. So what I chose was sort of one of the default ones for laying out this map. But if you want to go through and check it out in terms of other ones, you can change that, and that'll actually change that perspective for you. And again, sort of what we do first is sort of set up a projection. So this projection basically says, for that given shapefile, how should this be projected onto the screen itself? And for this first part here, what we're doing is literally just setting up a 1 to 0, 0, which doesn't change it at all. And what we can then do is sort of tie that projection, the one we chose here, to the projection we're creating here for the screen itself. And that's what this path, it's basically a path function, if you will. And so all that means is when we're feeding in the JSON sort of object into it and saying, okay, I want you to create this path based on sort of this outline, sort of above, let's say, this Pennsylvania. Pennsylvania has sort of, a specific outline. We want you to sort of change that perspective 1 to the one that we have set here and put the projection of the actual screen itself. So just kind of include these lines. One thing I'll make note of is the fact that once we sort of set this initially, we actually have to rescale it. And this is where that create scope comes into play. So you send the shapefile to it. It says, okay, I know the shapefile. I know what the sort of the width and height you're looking for, because these are sort of standard throughout, 800 by 1000. I'm going to create something called scale. Again, this is just a variable that we've kind of put together at this point, and it lets you say set the scale and set the translate. And again, you just kind of copy and paste a lot of these specific things. So from there, that'll basically recreate, correct that shapefile so it fits that 800 by 1000 screen. From there, we have a lot of similarities between the other ones we saw before. We're going to get rid of the whatever graphs there, and then we're going to create a new SVG object. And this is the only new part to it specifically is adding this path function. So we create a group, again, sort of just so we have it underneath a specific group. In this case, we're going to call it counties. And then we just append the path from there. So we feed it in the shapefile and its features. And one of the things I'll make note of as well, when you look at the shapefile itself, there's going to be a couple things. One is going to be features, is basically the data used to create the shapefiles. And then there is properties. Properties is basically metadata about those specific states or counties or whatever that shapefile specifically has. And that sort of terminology, features and properties, is pretty standard with shapefiles. So we just feed it in. All we want to give it is the features itself, so it knows that it needs to create these where the features are. So basically, it's going to know that here's the XY coordinates for all these features and all these different, in this case, states or counties, basically. So we know it has that sort of that information available to it, and then we just read it into the path, which again we created up here. So it uses this projection that we gave to it, and we gave it the projection in terms of the screen width and height at this point. So if we run this, what you're going to see is sort of what we saw before is basically sort of, here's Alaska, here's the United States, here's Hawaii. And as you can also see that Alaska kind of trails off because it goes around the world. It has some bits over here as well, parts of the state, a couple islands off to the side there. For us, we're going to be focusing on specifically creating a map for Pennsylvania. And this is where that properties comes into play that we mentioned before. So this next line here basically goes through, there's a lot of the same things that we talked about before, but one thing we want to change is actually, instead of using all the features, so for all the states, Alaska, Hawaii, the United States as well, we just want you to focus on specifically the Pennsylvania. And so what we can actually do is use something called a filter. A filter basically says, out of all this information, I want you to filter on basically one key characteristic or one key feature. And in this case, one of the properties that is given within this data set that we are able to put together is basically something called a state FP. And all this is sort of a an ID for each of the states. And it just so happens 42 is Pennsylvania. So kind of jumped ahead a little bit in terms of what this is sort of the main thing in terms of saying, well, we don't want to focus on the entire United States. We want to focus in on Pennsylvania. So we use a filter. And what this actual return is it's actually looking for some Boolean logic. So it's a true or false situation. So in this case, as it's going through each of the states, is the state FP equal to 42? Nope. Let's say New York. It says, okay, whatever that ID is, the state FP is for it. It's not 42, so we're not going to use it. So it's only going to return any true scenarios. So in that case, it's only going to find the state that is equal to 42, which I mentioned before is Pennsylvania. So instead of an entire data set, we're now focused in on specifically Pennsylvania and its counties. Nothing changes in terms of a lot of what else is going on here at all. So all it's doing is changing the data set that we brought in, that shapefile, that us.json file, and filtering it specifically for Pennsylvania. So if we look at that, we should see Pennsylvania. So here's all the variable, sort of all the counties within Pennsylvania. From there, we're going to need sort of additional information to actually sort of put all these pieces together at this point. And this is basically looking at sort of a resource that I also included. You go in here, basically, actually, let's go to their site real quick. Okay, Penn State sites, Pennsylvania State Data Center, and what it has is some metadata about various information across the counties. And so, one of the things we're looking at is population specifically. So I went through data and actually got through some of the census information and found per county information for population, and that's what we're going to be using for this map. So it's called PA, county, pop.txt. And from there, what I actually have here is a couple different things in terms of just kind of taking the data as it originally was and sort of reformatting it so I have population per county. And these IDs are sort of similar to what we talked about before. The IDs are for each of the counties. And so I have what it creates sort of in the end is this is actually an object which sort of says, okay, for each of these, we're going to have a population. So for each of these counties, based on their IDs, we're going to have a specific population. So we just use this section here to bring in that file, sort of parse through it, and so now we can actually utilize it for the rest of the code here. Okay, so in this step, again, we're going to have a lot of similarities between the last one and this one. Shape features is basically, again, sort of focused in on Pennsylvania, creating the same projections, doing all that the same as well. A couple of new things we have here is basically, so we want to color in these specific counties. So we're going to add a couple things to this information. And so for that, we would like to have, one of the things we're going to have for this is specifically, we're going to use that population data to sort of say, okay, based on all the populations of all the counties, we want to create a range from 0 to 1, because what we're going to have is this color palette. And this color palette goes from 0 to 1. So what we want to do is actually say, okay, for each county, we want to take the populations and set it so that the lowest population is labeled or sort of mapped specifically to 0, and the highest population is going to be mapped to 1. And so that will give us sort of that spectrum that we're looking for. I use a power scale, and I'll mention why here in a moment. But for the most part, all that this does is create a number between 0 and 1, so it can also be decimals as well, obviously, where it maps the lowest to the 0 and the highest to the 1. And then the palette is sort of a way to sort of express that within the colors themselves. And if you go to this particular site as well, you will see that there are a number of different sort of color palettes you can use. Diverging basically is one sort of color palette. We have single hues, so for sequential information. We also have multi-hues, and I specifically just chose one just to kind of take a look at different coloring and things of that nature. But for the most part, you can kind of mix and match in terms of what you want to have. So if I wanted to change it to this one here, all you'd have to go do is go find it and change that specific value. For the sake of argument, I'm going to leave it on, it's called plasma, is the color spectrum I'll be using. So now we basically recreate what we did before, as we saw before, and we just sort of read in. So for the fill, that's going to be the color inside the actual states themselves. You're going to go through the data. We're going to find the IDs, and for each of these IDs, it's going to have a value. So it's going to have a value for each of the counties. So if it's Allegheny County, it'll have the population there for it, as we sort of discussed up here. And it's also going to, you know, for all the other counties within Pennsylvania specifically, it's going to say, okay, whatever that value is, go use our scaling to map it to a number between 0 and 1, and then the palette will sort of take care of it from there. So the palette's looking for a number between 0 and 1, and it'll sort of apply the color specifically for that given value. So this is what we end up in you know, initially. So we can kind of see here, the Philadelphia area, Pittsburgh area, obviously has the highest of those values in that regard. So that's why they're sort of obviously a different color versus the other ones, which are kind of uniform in terms of their populations, and obviously not all the way. And I'll sort of mention this moving forward. But you got to remember one thing at this particular step is it's using populations. So if the population of the Philadelphia area or the population of the Pittsburgh area is much, much higher than the other ones, it's going to very much bias a lot of those values specifically to those areas and sort of mute the other ones. And again, there's a way to sort of correct this moving forward. So again, sort of this is our first sort of a map, if you will, at this point. One thing I'll make a note of is I don't include a legend here. Legends are actually something requires a little bit more steps than what I'm looking to sort of focus on here, but there is a great library that I would sort of just recommend checking out. That lets you sort of create these pretty straightforward in terms of that, but because it's external to D3, it's open source. It's just not an official part of the D3 library, if you will, but something I've used before for a lot of different projects. I check it out though, just to see, you know, you can put legends using this additional library, if you will. So like I said, we got Pennsylvania here, but we have a lot of bias specifically towards like the Philadelphia, the Pittsburgh areas specifically. So one thing we can actually do is sort of change that bias. So what we can actually do, and there's one step I'm skipping just for a moment, and just to talk about the color sort of variations. So back here where we have, so our next plot, we have the scaling power log plot. What we're going to actually do is change the exponent. The exponent basically says we're going to sort of, you know, sort of move the values, the smaller values, closer together, and sort of elongate the upper part of the tail, if you will. And so what that allows us to do is actually highlight a lot more of the larger populations that are just, so it's not 100% bias or majority bias towards Philadelphia or Pittsburgh. And so what we do here is basically you get a little bit more density in terms of some of these color areas, if you will. So we can actually change that from, let's say it's 0.5. The default value is 1, which basically uses a linear scale. But let's say we change it to 2. It's going to very much sort of bias our data sets to specifically those larger values. So obviously these Pittsburgh and the Philadelphia area gets sort of elevated, if you will. So what we want to do is actually, you know, create a more even scale. So let's say we set it down to 0.3. We run this, and now we're actually getting more variation in color because we obviously have some populations that are very low in Pennsylvania. State College obviously is one of the, you know, higher ones, but not relative to Pittsburgh and Philadelphia. So we can sort of play around with that. The last thing I'll make note of here is looking to add some point particles as well. Basically we want to add a point to this given graph. So for this case, you can actually utilize something called one of the Google API calls. Google API allows you to actually sort of say, given an address, give me the latitude and longitude of that given address. And so the Old House Lab was where I was actually giving the live version of this. So I was like, oh, why don't I just use that location? And that's what's listed here. And then it gives you all this meta information. So Old House libraries, it gives you a bounding box if you're interested in that, or specifically a location. So this is the latitude and longitude of that location. Okay. And change this a bit. So there's our point. And so all we're doing here is, again, following the same procedures we did before with Pennsylvania. We're changed a little bit in terms of the bias, in terms of the exponent. And the only thing we're going to add is a location for State College. And that's, again, sort of being computed here using the Google API call. So now we just add a point, so a circle, and give it sort of the CX, CY, so its location, XY position. One thing I'll make a note of as well is that one thing you have to do is the fact that the latitude and longitude is basically sort of ubiquitous to any map. Again, sort of using the idea that the shape files are specifically sort of set up so you can sort of append it to whatever projection you're looking at. The projection we created up at the top in terms of that the projection magic that I kind of talked about before, we've set up the projection at this point. And so we have to actually run that latitude and longitude through here. So it knows that it's not specifically, so if you think about this, if we were placing a point on our screen here, you know, with a longitude -77, it would be off the page somewhere. And so what this does is basically uses the projection that we've created for sort of seeing the United States and also for Pennsylvania, and it's mapping it now to the 800 by 1000 screen. And so it'll say, oh, I know this location based on this projection, this latitude longitude needs to be mapped to this actual location within the 800 by 1000 display. And so that's what we're doing here on that step. And so now it knows specifically where to put that circle. So we have a point, and this should be mapped to specifically to the Dollhouse Laboratory. And I just changed the opacity of the fill so you can actually see the point. And so you can add a little bit more back if you want to. So let's say 7, refresh this, and you can still see your point for that. And so you can actually do not just one point, but you can do multiple different points. But this is just sort of a simple sort of step-by-step way of how do I capture a actual latitude longitude using something like a Google Map API, and how to map it to specifically one of our plots as you see here. So that's basically what I wanted to cover today in terms of both the network plots and the map plots as well. So hopefully you can kind of follow through. And if you run into questions, please always feel free to contact me. I can follow up with these particular documents listed on GitHub. You're more than welcome to share if you'd like to in terms of sharing some of these resources. And eventually, if you have any questions, please let me know as well. So I thank everybody for your time. And if there's any follow-up questions, please let me know. Thank you. Have a good day.